Welcome to the next module of Theory of Machine 2. So we are learning unit number 5, Synthesis of Mechanism. In the last class we have seen inversion method, 3 position synthesis of your 4-bar mechanism by graphical method. So same method now we have to apply for slider crank mechanism, and we have seen in the mechanism one link length should be assumed so that we can trace the various link and we can find out the dimensions of various link by method of inversion. Okay, so I think you understood how to solve this 4-bar mechanism by using inversion method. Now next is slider crank mechanism. We have to synthesize by inversion method. Again we will see 3 position synthesis. Okay, so let's start. Now this is the problem statement given. So such type of problem comes in the exam for 10 to 15 marks. Okay, so that's why you have to make more practice. You have to take various problems and solve on your sketchbook. Anyway, now we will come to our problem. Here it is given that synthesize slider crank mechanism by inversion method using the following data. Here it is mentioned in the question inversion method. So you have to solve this problem by inversion method. If it is not mentioned by which method you have to solve, then you can use any method. Just writing the answer by using this method, solution is given like this. So you have to write in the answer sheet. Here, so data is given. So first one is stroke displacement. Initially it is 30 mm. In slider crank there is a piston. So there is a stroke of piston. So stroke displacement it is given initially 30 mm. Then total displacement of the slider it is given 60 mm. Next one is initial position, it is given 30 degree initial position of crank. Then second position angle of crank it is given 60 degree, and eccentricity is given, that is 15 mm. So sometimes this notation is not given theta 1 to theta 1 3, only it is mentioned initial position of crank, second position of crank, like this. So you have to write down like this, theta 1 to theta 1 3, correct? Okay, now here first write down the procedure and then we will solve, okay, on our sheet or maybe on the sketchbook. So such type of problems, that is slider crank mechanism, we have to follow some the standard procedure. So what is the procedure? So number one, first of all draw two parallel lines, that is line 1 and line 2, at a distance e apart. E apart means eccentricity whatever given, you have to draw the lines 1 and 2 e apart. Okay, so in this problem here eccentricity is given, that is 15 mm. So what you have to do, take a drafter or roller scale, draw one line. I have shown the center line here. Okay, draw any one line. Okay, then draw other line parallel to this line, and distance between two lines is 15 mm. It is given in the problem. If it is given 25 mm, then you have to take 25. Whatever given, you have to take this. Now this is 15 mm eccentricity. Okay, so two parallel lines we have drawn. Next, take an arbitrary point, any arbitrary point a1 on line 1. So what you have to do, take any one point on the line 1, mention this is line 1, this is line 2. So take any arbitrary point on line 1. So I have taken here, you can take here, 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 whatever, but on the line 1. So I have taken a1 on the line 1. Next, take another arbitrary point C1 on line 2. Take another arbitrary point C1 on line 2. Now, while taking point C1 on line 2, so see that A1 and C1, there should be some angle should be there. So this way you have to take C1, correct? You can take anywhere, but for drawing it will be then it should not be complicated. So while point marking the point C1 on line 2, so just see that A1 C1, if you just put a scale, there must be some angle at a some long distance. Okay, so proper distance, not more long, not too short like this. Okay, okay. Next, mark point C2 and C3 on line 2. You have to mark point C2 on and C3 on line 2 such that C1 C2 is equal to initial displacement of slider, that is S12. C1 C2 is nothing but initial displacement of slider, that is S12 30 mm, and C1 C3, that is equal to S13, that is final position of slider, that is equal to 60 mm, that is given in our problem here. Initial displacement 30 mm, total displacement of slider 60 mm. So you have to mark C2 and C3 such that C1 C2 is 30 mm. So C1 C2 is 30 mm. From C1 you have to take 30 mm distance and mark point C2, correct? Then from C1 you have to take 60 mm distance and mark point C3. So this way you have to mark and give the year dimensions like this: S12 equal to 30 mm, S13 is 60 mm. Okay. Then join A1 C2 and A1 C3. Join A1 C2 and A1 C3. What you have to do? Join A1 C2 and A1 C3. Okay, we have joined. Then next is rotate point C2 about A1 through an angle theta 12, that is in our problem it is given 30 degree, to obtain C2 dash. So what you have to do? Now rotate this C2. So take distance in the compass A1 C2 with A1 as a center. Draw an arc from point C2 like this dotted arc. Then what you have to do? By using angle protractor, so with reference to A1 C2 line, take an angle theta 12 or mark an angle theta 12, that is equal to 30 degree given in the problem, and draw a dotted line at an angle of 30 degree with reference to A1 C2. This line and this arc meet somewhere, mark that point as C2 dash. Understood? Okay. Next, then rotate point C3 about A1 through an angle theta 13, that is equal to 60 degree, to obtain C3 dash. Here again take distance A1 C3 in the compass with A1 as a center. Draw an arc from point C3, dotted arc. Now I have drawn like this, correct? Then with reference to line A1 C3, take an angle theta 13, that is equal to 60 degree, and then draw a line at an angle of 60 degree. So this line and this arc meet somewhere at point, mark that point as C3 dash. Next, then join C1 C3 dash and C1 C2 dash and draw perpendicular bisector of C1 C2 dash and C1 C3 dash. Now here what you have to do? You have to join C1 C2 dash and C1 C3 dash. Please remember this. You have to join C1 C2 dash and C1 C3 dash. Okay. Then what you have to do? Draw a perpendicular bisector of C1 C2 dash. So I have drawn like this, dotted, dotted, dotted. Then draw perpendicular bisector of C1 C3 dash. I have drawn like this, dotted, dotted, dotted. This perpendicular bisector intersect at some point, that is mark that point as B1. So I have marked that point as B1. The bisector will intersect at point B1. Then join A1 B1 and B1 C1. So join A1 B1 with dark line, then B1 C1 with dark line. So A1 B1 represent the crank, whereas B1 C1 represent connecting rod. Okay, so this way you can synthesize slider crank mechanism, then measure length A1 B1. Now for my case it is coming 59 mm, and connecting rod length, that is B1 C1, it is coming 98 mm. Again 5 to 10% is acceptable, not more than that. Okay, so there is a one note. In two position synthesis of slider crank mechanism, the length of crank must be known for determining the length of connecting rod. But in case of three position synthesis of slider crank mechanism, the length of crank and connecting rod both will be determined graphically. So this is the just difference between this two position and three position. So have you understood? Okay, so this is very good method of inversion, very easy. So you can get the answer. Now next method we will see in the coming class, in the next class. Thank you.